Hi, this is Judging Hu. This video is for the probability homework 7 problem 8. So in this problem, we got a portion process question. So we have these three features for the portion process, and for the question A, we need to figure out the expected value for this portion function, and question B, we need to figure out the T1, T2 for this portion function. Well, first of all, in this function, which is the Pn T1, T2 is equal to K, the probability of this is equal to the e to the negative lambda t times lambda t to the k and over the sum of k. Well, for this function, we have a similar portion. The general one, the general portion expressed as we mentioned before. So we have the feature. Well, it's right in here. The feature is in the portion distribution. For px is equal to k, the possibility is equal to the e to the negative a times a to the k over k. The mean value, which is also the expected value, is equal to a, and also the variable is equal to the mean value and is also equal to the a. Well, for this problem, it's just use the lambda t to substitute the a, so we can also have the features that the expected value for this whole function is equal to lambda t, which is the a, which is this part. And also we have the variable is equal to the mean, which is equal to the lambda t, which also this part. And we got the expected value for the x squared is equal to the variable value times the mean square, which is the lambda t plus lambda t squared. Okay, so we got the question A's answer. Then for the question B, we need to figure out the Rt1, T2. So for the Rt1, T2 is equal to the expected value for the xt1 times xt2. Well, in this part, we use two situations to discuss it. For first situation, when the T2 is bigger or equal to T1, we got the expected value like this, which is because the xt2 is equal to the xt2 minus xt1 plus xt1, because these two can cancel each other, and we can got this. So we just divide it as the expected value for xt1 times this part, which is the expected value for the xt2 minus xt1, because also it is linear. So we got the expected value for xt2 minus the expected value for the xt1, then times the expected value for xt1 times xt1, which is the x squared t1, which is this part. So for this part, the x squared part, we can figure out it should be lambda t1 plus lambda t1 squared, which is we discussed in the question A. So which is this part. And for this part, the xt1's expect value is the lambda t1, and the xt2's expect value is the lambda t2. So we got this, and just time, we'll just calculate this. It will be lambda t1 times lambda t2 plus lambda t1. Well, it should be the minus lambda t1 times lambda t1, which is the minus lambda t1 squared. And because it can be cancelled by this part, the positive lambda t1 squared. So we just move it to the back and cancel each other. So we got the final answer is the lambda t1 times lambda t2 plus the lambda t1. So that's the situation for the when the t2 is bigger than or equal to t1. And then for the second situation is for when the t1 is bigger than or equal to t2. So similarly, it can be expressed like the expect value that the xt2 times the xt1 minus xt2 plus xt2. So just repeat the same procedure. We can get the final answer for the expect value is the lambda t2 plus lambda t1 times lambda t2. So the second, well, how to say this? Well, the second part for the answer is the same, and for the first part, the difference is to the choice of the t1 and t2, and we can figure out that this choice is related to the minimum value of t1 and t2. So we can write down the whole express like this, which is the rt1 t2 is equal to the lambda times the minimum value of t1 and t2, then plus the lambda t1 times lambda t2. So that's it.